You see the Eiffel Tower every day, in photos, in movies, on postcards. You trust it completely. But its legendary stability rests on something almost invisible. Millions of small rivets, and the factory precision that placed every single one perfectly. In 1887, building a 300-meter iron giant seemed impossible. Critics called it a monster, said it would collapse in the first strong wind. Yet it rose, stable from day one, in just over 2 years. Here's how precision riveting and prefabrication turned ridicule into one of engineering's greatest quiet triumphs. The challenge was enormous. Artists signed a famous petition calling the tower useless, dangerous, an eyesore. They feared wind at that height would rip it apart. Gustave Eiffel, the engineer whose company had already built record-breaking metal viaducts, saw something different. He refused to build it like a medieval cathedral, piece by piece, guessing on sight. Instead, he treated it like the world's most precise giant puzzle. Every single component calculated, cut, drilled in advance. At the Levallois-Perret workshops, just outside Paris, thousands of wrought iron pieces were born. Each beam, each brace, traced exactly, cut to the millimeter, drilled with holes positioned to tolerances tighter than a coin's thickness. Think of it this way. Imagine building giant IKEA furniture, but every hole is pre-drilled so perfectly that when the pieces arrive, they snap together without a single adjustment. That's prefabrication at this scale. Sections were first loosely bolted together in the factory, alignments double-checked, then disassembled and shipped. The construction site became an assembly line, not a battlefield of improvisation. But prefabrication was only half the secret. The other half, the part that truly locked the tower together, was hot riveting. A rivet is simple, a short iron rod, one end already has a head. Heat it glowing red until it's soft as clay. Push it through 2 perfectly aligned holes. Then hammer the plain end, forming a second head. As the metal cools, it shrinks. That shrinkage pulls the iron plates together, with a grip stronger than any modern bolt. A 4-man team worked each rivet high up. One heats, one inserts, one shapes, one hammers with a heavy sledge. The clang, clang, clang echoed day and night. Most rivets were set in the factory using machines. Only final connections happened in the sky. So how did all this keep the tower rock steady as it grew taller? That's where the genius really appears. The 4 giant legs rose together, at mathematically exact angles. They had to meet perfectly, 57 meters up at the first platform. One tiny error at the base would become a disaster hundreds of meters higher. Because every piece arrived pre-tested and pre-aligned, assembly stayed true. Engineers even used sandboxes and hydraulic jacks in the foundations. They could nudge each leg to within 1 millimeter, about the thickness of 2 credit cards stacked together. The open lattice let wind pass straight through, instead of slamming against a solid wall. Like a picket fence versus a brick wall in a storm, Eiffel's curves were calculated so wind pressure actually helped compress the structure, safely. Here's the part most people never notice. Even today, in a strong gale, the top sways only about the width of your spread hand, at nearly 300 meters up. That's not luck. That's deliberate design, absorbing energy instead of fighting it. The tower was finished March 31st, 1889, right on schedule for the World's Fair. What was supposed to be temporary became Paris's eternal symbol. The real legacy stretches far beyond Paris. This project proved prefabrication and precision riveting could create enormous structures, fast, safe, strong. Those same ideas birthed the steel skeleton skyscrapers we live and work in today. Modular building, used everywhere from emergency shelters to giant stadiums, traces its DNA back to Eiffel's workshops. The tower itself was almost demolished after 20 years. Its radio antenna saved it, proving great engineering creates value that lasts. Eiffel didn't just build a landmark, he showed the world a smarter way to build, forever. The next time you see the Eiffel Tower, in a photo, or standing beneath it in Paris, pause for a second. Look past the romance. See the millions of red-hot rivets. See the factory precision behind every graceful curve. You're looking at thoughtful engineering, the kind that anticipates problems, and solves them before anyone ever notices. That's exactly why we tell these hidden stories here on Hidden Stories of Engineering. Not just the famous disasters, but the quiet successes that hold our modern world together every single day. The most reliable things around us often hide the most careful work. If this story of invisible precision changed, even slightly, the way you look at one of the world's most famous structures, please hit that like button. Share it with a friend who loves history, architecture, or just good engineering. And if you're not subscribed yet, join us. We've got more forgotten innovations, critical decisions, and life-shaping fixes coming your way. Stay curious out there, and thank you for watching.